Let's move on to number 19 where it says what type of conic section is represented by r equals 8 over 16 plus 125 sine theta. What in the world is that? Well, let me tell you first of all what a conic section is. And we've talked about these individual things in varying degrees. We beat the mess out of circles and ellipses. You know what a parabola is. Hyperbola, and we've discussed this very briefly, but a hyperbola is shaped kind of like this. And there's another shape to it. It looks kind of like the side of a basketball, doesn't it? It could do this, or it could go like this. There's a lot of explanations for why it does that and a lot of practical uses for it, but in the meantime, that's the general shape of it, just in case you don't remember what it looks like. I'm not going to draw the others because you know what they are. Let's go back to this equation and think about that for a second. R equals theta. Okay, so we don't have an x and a y. So we know it's not a regular function. What we do know is that we have an r and a theta, so we start thinking, well, boy, howdy, I better not be in function mode. I better be in, oh my goodness, which one is it? And I just pressed mode in case you weren't watching. Slide this over so you can see it. You couldn't see that where it was, now could you? Function, parametric, polar, or sequential, which we didn't talk about, so I'll tell you it's not sequential, and we've already ruled out function. Is it parametric or is it polar? Okay, well, polar is round, okay? You ever see a picture of the North Pole? And there, I mean, like, not a picture of the North Pole, like, oh my gosh, here's Santa's workshop, but a picture of, like, an aerial view of a pole, and it's like this, and it does that right there, and it's round. And we dealt with this in class, but basically, if I was going to be dealing with polar equations, then I need to deal with two things. I need to know how far out I'm going, that would be my radius, and I would need to know what my angle would be, and that would be my theta, so r and theta. So this one is polar, and in case you can't remember, polar, here, let's kind of write it out. Polar, look, there's an r and a theta, there we go, polar. Parametric would be completely different. Parametric, oh, look, it has a T in it. Those are going to have a T in them. Okay, anyway, now we know. So we need to make this calculator go in polar mode, and we'll press y equals, which is no longer y, but it's r, and we'll type it. 8 divided by parentheses, because that entire denominator involves more than one term. 16 plus 125 sine theta. Close out the parentheses on your theta and close out your denominator, and you probably are, but make sure, in case they don't tell you it's in degrees, assume it's radians. So press mode again. Let's make sure we're in radians and not degrees, okay? Make sure you're in radians, make sure you're in polar, make sure you have that, and now, not even worrying about zooming or anything, I'm just going to hit graph and see what happens. Well, that's odd. That's kind of hard to tell what it is. I don't know. Actually, I do know, but I'm not going to tell you. So let's think about it for a second. Well, is it a circle? Actually, let's not rule that out. Let's consider the possibility that we can't see this entire thing. Maybe it is a circle and it's really big, or an ellipse, or a hyperbola, or a parabola. I'll go ahead and tell you. Right now I'm thinking it's probably one of these. But just to be on the safe side, let's hit zoom, and we're going to zoom out. Now, I'm just going to show you a few little things about zooming that I think are going to help you on problems like this. Here we go. So I'm going to go to zoom out, and just from the origin, right there, you see my cursor is blinking on the origin. Yours might be too. You press enter. There we go, and we see that, and we see that. Well, clearly it stopped. And so it didn't make a complete cycle, so circle is out, ellipse is out. So it's either hyperbola or parabola. We might be tempted to go ahead and toss out hyperbola because we only see half of it, but sometimes those kinds of things happen when you're dealing with a polar equation. So let's be a little bit careful. Alright, basically my question is, are we looking at the top half of a hyperbola or are we looking at a parabola? Let's keep going. I think we should deal with some zooming just a little bit more. I'm going to go zoom box. I'm a zoom box kind of guy. Not Zumba, that's different, but zoom box. If you hit zoom in the top one, what I think you should do, and this is just personal opinion, is just tinker with the window here, and I'm going to get it to one corner. What I'm going to try to do is drag it from this top corner down to about here, and I'm going to see what the general shape of that is. So if I press enter, it's going to start this little box. You can move your arrows And you can see the box. See, once I hit enter, it's going to show me what this thing looks like. It's going to zoom in on that box. It's just a neat little trick. Press enter. Okay. The general shape of this is either half of a hyperbola or it's a parabola. It is incredibly straight, and parabolas are not. Now, the way I've drawn my hyperbola here, it looks straight. But let me give you a quick lesson on hyperbolas. Hyperbolas are, I love this word, they're asymptotic. What they'll be is there'll be this little line that goes through here, and it's asymptotic with that line. So I didn't quite draw this right, but basically it's going to get closer and closer to this line. We dealt with asymptotes earlier. And as it gets closer to the line, it's going to look straighter and straighter. So hyperbolas are often, I'm just going to write this down, often straighter looking than parabolas. Parabolas are clearly bent, and that one is not. Parabolas, you know what they look like. They look like a kind of a U or a smiley face. And these are clearly straighter. Now, I'll go ahead and tell you they're not perfectly straight because it's a hyperbola, but it does look straighter. It has that appearance, and so therefore the answer is C.